Good afternoon, everyone. Welcome to this webinar entitled AI-Ready Data for Learning Health Systems, From Interoperability to Data Utility, an Enterprise Strategy for Trusted AI and Data Utility. The webinar is sponsored by InterSystems. Running from 1 o'clock to 2 o'clock p.m. Eastern Time, this webinar is being recorded for future viewing purposes. Once the webinar has concluded, it will be freely available on the AMIA website in the Education Catalog. You may find it by using the filter for Industry Partner and On Demand. There will be time for questions and discussion during the final portion of the presentation, so as you think of questions throughout the webinar, please type them into the Zoom chat area. Questions will be addressed during the allotted Q&A time. Now, I would like to introduce the presenter for today's webinar, Julie Smith, Head of Healthcare Global Market Strategy at InterSystems.
Thanks so much, Dina. We really appreciate the opportunity to talk with everyone today. And as Dina mentioned, I do lead Global Healthcare Market Strategy at InterSystems, but I really started my career in healthcare as an emergency room nurse. So this topic is incredibly near and dear to my heart and important, particularly in the era of AI. We've been talking about ready data, interoperability, all the different pieces that are involved in getting data access and actually making it usable. But I feel like for decades, and yet we have some new questions to answer in the era of AI. And so I think that is really where we're going to spend time and focus today. What does it take to be trusted, governed, contextualized, all of the things that are necessary in order to achieve the outcomes that we're looking for. So today I have the privilege of presenting with my counterpart, Jonathan Teich, who is our Chief Medical Officer, and I'm going to hand it over to him to get us started by introducing himself and then getting us going in terms of what are we really talking about and how do we frame this problem.
Great. Well, thanks, Julie, and thanks, Dina, and thanks to AMIA. So, hi, folks. I probably know a lot of you, I think. I'm Jonathan Teich, InterSystems Chief Medical Officer and Director of Clinical Innovation. I'm an emergency doc at Brigham and Women's and professor at Harvard, and an AMIA lifer, really, for 30-something years. So, well, I've worked for hospitals and academic centers and for government and for industry. And kind of like Julie, I really focus on what does information actually do for healthcare? How is it going to support care, operations, workflow, and then moving upward to public health, to research, to supporting health plans? What functions should the interoperability solutions actually handle, and what are the AI use cases that we see? I spend most of my time on AI now, and as I'm sure you're all aware, AI has opened up really incredible new worlds in all of these areas. Just an amazingly fast evolution from plain documentation and summarization up to facilitating actions and guiding processes, applying medical knowledge and feeding the learning health system. This diagram, which I first did in 2023, I've changed about 7 times because new functions and new capabilities add themselves every 2 months or so. It really kind of evolves from left to right, starting from basic, on the second column, basic actions, documentation, and being able to produce summaries and orders, through process support, through the advent of agents, through quality with the advent of decision support, and then all the way up through population and operations and full-scale concierge-like support. And all of these rely on what's over on the left there, which is the different kinds of data that are continuing to add on. Multi-site data, multimedia data, text data, all kinds of things that you never really had the benefit of working in before. So let's use this as our basis, and let's move on and talk about where a data utility plays in this. So all of this pretty much is based on having usable data. Multimedia data, multi-formatted data, widely different data that can come from multiple sites. We're mainly talking about generative AI when we talk about AI these days, but this really applies to machine learning and to digital twin generation and to everything that we now kind of ironically call classic AI. Throughout the machine learning literature, you'll see paper after paper which cites the problem with getting high volume data, high reliability data, interoperable data in order to actually get some value. it's no less a problem in generative AI. And health systems really can't stop at just aggregating data. They can't really stop at even generating insight. They have to close this loop that you see here, from data to insight to action to outcomes back to learning. Each one of these things begets the other. Data begets insight, insight informs action, and all the way around through learning, which will inform the next decision and maybe the next collection of data. So AI has some wonderful abilities to accelerate that cycle, but only when the data foundation and the workflow integration are both mature enough. And that's where we start using the term data utility. So a data utility is a foundation of data that can be applied to all of these meaningful functions, not just a database, but all of these capabilities, all of this support. Every one of these examples we're showing on the right here, care gap alerts and the rest, is really only possible when the necessary data is available in a meaningful, usable form. Let's go on. So,
Jonathan, I might just jump in here and say, and I think one of those important caveats. Oh, go ahead.
Sure, go ahead.
I think one of those important pieces to call out in this is that it's within the workflow. And one of the things that we continually see when we think about data utility is the idea that it needs to be available at the time where it already fits into the practice involved. And when you think about the examples Jonathan called out, the care gap alert or the work list and referrals, if you have to go external to your system, then that value really drops and we are not seeing the actions and outcomes and learning that we might be looking for. Back to you.
Thanks. Let's go to the next one. So what is it about a data utility? What makes a data utility more than just another good pile of data? What do we actually need from a data utility to achieve these goals? Of course, a data utility has to store and fetch data and make it available. But the question on the center of the screen really captures it. Can we trust the data? Can I use the data and can I learn from the data? So, when all of these are yes, then we've got an effective operational system and an effective foundation for a learning health system. Really, out of these three, trust is really what makes adoption, makes or breaks it. If clinicians don't trust the data, they're not going to use it, and none of the rest of the benefits accrue. So, there's really a whole ecosystem evolved. If you think about these 5 points on the right, there's really at least 5 practical priorities. One, I have to govern data as enterprise infrastructure with all of the necessary protections and permissions and organizations that you might have to see. I want to standardize data so the meaning stays consistent. I want to preserve the clinical context so that the data means the same thing, so that if I'm trying to find out if someone was a smoker, I have 55 different ways to capture that. Can I actually have things that actually mean the same and can be used in context with each other? Can I, as Julie was saying, can I integrate this into the workflow? Can I make sure that the data is not only available for a research project, but it is available upon request, or it's even available when it senses that certain data, certain presentations are needed? When you have these autonomous systems that can make use of this data to give you the information you need, even unbidden. And then, of course, you want to be able to measure this. I want to measure what actually happens. I want to know whether the insights that were given, the interventions that were recommended, did they make a difference to the patient? Because only through there am I going to be able to learn what happens with these patients in the aggregate. Only through there am I going to be able to generate new knowledge out of this. Now, we talk about standardization and preservation of context, and you might say, well, my data is consistent; it all comes from one source. And when you do, I will smile benignly and say, nope, that ain't the case. Even if you have a local system and you're basing most things on your EHR, there's still all kinds of departmental variations. And I'm sure those of you who've worked in this have seen that now, the many, many different ways that the simplest thing can be represented. And now expand that to doing any kind of multi-site work, any kind of multi-center work, and you'll find out that one epic just is not the same as every epic. So all of these different attributes are really necessary. So let's go on. So AI is kind of raising the bar of this. Julie, I think we're off screen shots now.
Do you see it?
We do not. We do not actually see it. But I
Hey,
will.
Dina, do you see it on your side?
No, I don't see your slides.
Interesting. All right, let me pull out.
Okay, I will talk because this next slide doesn't really require that much visuals, and I'll let my tech support team get in the job. Uh, so AI is really raising the bar. AI puts new pressure on any kind of weak. There you go, and now we're getting somewhere. Um, AI puts new pressure on any kind of weakness, any kind of gap in the data foundation. Gaps in completeness, gaps in accuracy, meaning, provenance, timeliness, anything that doesn't work quite right here is magnified through AI because it's going to try and make all these inferences. And if it's trying to make inferences from data that's partial, it's going to start guessing, and we know where that takes us. So these are all problems of reliability and therefore trust and therefore adoption. So interoperability helps us. It helps get us the data we need, but it's not the total finish line. It's really the starting point for something that's a lot more demanding. To use the range of data types that AI needs, we have this kind of sequence that you see. We start by learning to connect and exchange data. Next, we have to be able to review, rehash, be able to check and monitor and make that data trustworthy. And finally, we need to use the data in a useful fashion. And sometimes the data was designed to be to the benefit of the database generators. If you want the data to be to the benefit of the researchers or the clinicians or the patients, it's probably going to have to be organized in ways that might not be the way it started out. But if you want that, then you can get data that can influence decisions, trigger workflows, support continuous learnings. But it's really something where, especially with AI agents, especially now that AI is taking on a whole process function, you really need to be able to understand whether this data is not only trustable, but also formatted for best usability. So in this context, interoperability is really the floor, not the ceiling. So I'm going to turn it back to Julie. Let's talk about what the evidence shows and what the health leaders themselves are telling us.
Thanks, Jonathan. So when we start diving into the data and the research on how the current position of the market and what barriers there are and what the perceptions are overall, one of the things that we consistently hear is that, to Jonathan's point, interoperability is the floor. In fact, if you ask health leaders like you, which functions do you believe interoperability solutions should handle? Data transport falls right in that middle because it's almost presumed at this case, right? We know how to connect pipes. Not all the pipes may be connected yet, and yet that is a very familiar paradigm that we understand and have been doing now for decades. And the needs that are surfacing, particularly in the era of AI, have really shifted towards those first three columns. That data normalization and mapping matters. Quality checks and remediation matters. Terminology and code standardization matters. And we see this very consistently when we look at the data. And I think one of the key pieces is because the sheer volume of that data is so large, to actually extract meaning out of it, to have that data utility, it really requires some additive services. And I think that's borne out in research that we run across. In fact, when we ask questions around what are the top 5 barriers for data utility, what we hear is that very first row of sometimes things are not yet connected, right? Community partners lack EHR interoperability. And yet a huge chunk still centers on those same challenges around mismatch in standards, mismatch in formats, the cost and resource constraints, and we'll talk about that a little bit more in terms of how much of this is done manually today. And then the huge variety of patient privacy and consent challenges, when we think about crossing the 50 states, to the territories, the federal guidelines, all of the different protocols in place, making sure that we're doing this in a safe and privacy aware manner has been a challenge. And then obviously the skills involved in making this work at scale. What we see consistently is that across every maturity level, For AI and really those advanced population health strategies and the work that's necessary there, it has to start with that trusted data that Jonathan mentioned. And that is only facilitated when there is governance, stability, context-rich data, or else you cannot have confidence in the clinical or operational answers that are generated out of it. And when we dive further, what we actually see is that it's moved downstream. We now see healthcare leadership across the board not really talking about the exchange itself, right? We have our national networks, we have all of the various alliances, associations, but really they're asking more targeted questions around how is it prepared, how is it standardized, how is it delivered for analytics, because particularly with AI, it really requires such significant effort, or else the answers cannot be trusted. In fact, 86% of leaders say preparation and readiness is where the value really sits to enable that. And that data readiness is not a connection problem. It requires that repeatable process involved in order to actually solve for those use cases Jonathan showed in those beginning slides. So when we take this further, what we see, particularly in the era of AI, is that trust once lost is a really hard challenge to get back. And trust is very often the real adoption barrier because it requires the transparency, the auditability, the insight into the end-to-end workflows that are involved when you bring in AI. Because when you bring in AI, you can't always know how those decisions were reached. And so that is actually one of those big factors in determining whether a pilot moves forward. In fact, 45% in some Chime research showed lack of trust in data accuracy or quality as a barrier. Formally chartered data governance, again, the processes involved to ensure it's actually flowing accurately and correctly with oversight. And then the reality is that many organizations are still on the path and the road to developing these processes and policies. And so there's a long on-ramp when you think about governance in particular as the foundational infrastructure for AI scaling responsibly. And what that means is that there's really a large breadth and depth of actions that are required to get to that true data utility. That is not just an availability question, but also a quality question and an automation question to get there together. In fact, Chime has recently said that data quality and governance can no longer be a supporting function, but has to be viewed as a strategic asset. And in fact, Philip Payne, who you all know from AMIA, recently spoke at one of our forums talking about the reality that you cannot have an AI strategy without a data strategy. And you cannot have a data strategy without an interoperability strategy, just really speaking to the stepwise approach that's required to be able to use AI at enterprise scale on enterprise data, and how important it is to be able to marry all of those steps together to actually get to success. So if we think about this, again, in those stepwise fashions, we see across the industry really sort of building blocks in the interoperability journey, getting to AI-ready data. If we think about the basics of AI utility, it may be as simple as foundational organizations that exchange PDFs where you could, in theory, see the data, and yet it very often is not usable. In fact, we have some data points that say, the average patient record grows by about 4 megabytes a year. And when you think about that in terms of number of pages, right, that's at least a novel or two worth. And so who can, sift through all of that in a PDF document generated environment and actually find the meaningful tidbits. Jonathan as an emergency room physician, me as an emergency room nurse, when we have those patients present, we are not looking through what could be really reams and reams of paper. But that is the place that we've started. And that has been, for the data, fairly successful when we look at the adoption statistics for interoperability as a whole. And yet when you move to that next level of sharing that data in not just a document form, but in the structured fashion, right? If you can parse that CCDA, for example, if you can do it as FHIR resources, and you can send it bidirectionally, then you have an opportunity to really sort of extract some more meaningful pieces. And those organizations that have been doing that for many years we've built out those reports, right? Those specialty specific summaries. We've extracted it and tied it to LOINC codes and SNOMED and all of the different ways that we want to do it to sort of say these are the things that are likely most meaningful to us. And then really that next step is how you can actually embed it again back into those workflows and have it in a way that is trusted and can actually lead to decisions. And that is where we are on the cusp with AI. That because AI can actually extract data from all three of those levels, there is an opportunity to leapfrog and jumpstart many valuable use cases. But it all depends on making sure that the data itself is usable. And when that actually occurs with trusted, contextualized, governed data, then that's when change truly occurs. And that's where we see it actually happen in care delivery, in research, in operations, in all of the areas that we've historically had to do very, very targeted use case, problem specific solutions to do it more at enterprise scale and think about it more holistically, to then really think about it in terms of what are the most important pressing questions, problems that we need answered within our organization, and what does the data need to look like in order to actually deliver on that. And that's where we actually see those really innovative organizations stepping and then defining down from a data utility perspective and a traceability perspective to get the answers that they need in a way that is verifiable and can actually trace all the way through in a closed loop fashion. So with that in mind, you think about I think I jumped again. I'm trying to get this working. All right. So then when we think about what does this mean from an entire enterprise perspective, this is where you have the opportunity to not think about the data silos that exist, not just the clinical data or not just the operational data or financial data, whether it's in an EHR or ERP or CRM, all of the different types of applications that are used within healthcare organizations, but actually thinking about it as a true governed enterprise data foundation for all of the variety and complexity that's involved in the enterprise data. And then to say, how do we bring that to scale? Removing the manual workflows that are currently available and actually having it supported with the technology itself, where the technology is no longer just the pipe, but it is actually doing all of those other features and functions that are necessary. It's doing data cleaning, data aggregating, data normalizing, all of those pieces to get it into trustworthy contextual information in a way that's needed. Because that is truly the pathway we see for trusted AI getting to scale and no longer staying in siloed pilots. That it really requires the enterprise level capabilities and an enterprise level governance model in order to get there. And that's where we see it actually then feeding into all of the subsequent use cases. I'm going to hand it back to Jonathan to dive in a little further.
Sure. Thanks, Julie. So let's hit up the data foundation one more time and really kind of sum that up. And then we'll talk about a lot of the surround that has to be produced in a data utility to not only have the data, but also to make it support your goals. So, we showed a diagram like this before, And when we're talking about AI-ready data, we're really talking about the things that are around that circle, right? We want trusted. We've said this before: trusted, governance, standardized, timely, put into clinical context. You need to know where the provenance is, where it comes from, how it was transformed, and whether it's complete and appropriate. The fact is that data fit for purpose can be different for different purposes. So you have to have something that is generalizable and can drill down to being specific for one task or another. A data set that's good enough for trend reporting might not work for clinical decision support. A data set that you're using to generate research hypotheses might not be good for automated, sort of concierge type operational action. So the whole utility is an enterprise function, and you have to think in advance of the different categories of things that it's going to serve. Again, through research, through operations, through clinical work, through patient-centered things. So it's not a one-time data cleaning project. It's really a matter of getting a foundation that says, if I do data in this model, then I'm likely to be able to have data that I'm acquiring into that model that suits this purpose and also that purpose and also that purpose. So that's really kind of the crux of where data utilities do a good job putting data together. But now let's talk about the fact that an AI data utility is a whole lot more than data. And I'm thinking about things that we do at InterSystems, and we'll talk about us in a second, just save one last slide to be personal. But when you're thinking about executing AI, when you're thinking about a system that makes this run, it's more than just the data. It is all these things on the left. It is the ability to have vector stores and vector embeddings. So when you're collecting, especially important if you're collecting multimedia, if you're collecting text, think about trying to use a patient's 200 notes and be able to get insights out of that. That's too much for current data windows. So we do vector embedding, we do bracketing, we do chunking, and we'd be able to do a lot of different things that allow us to match exactly what I need to apply to my final question. We do RAG, and that's really a lot about using your own data. I can use a large language model, I can use Claude, I can use GPT, but I also want to be able to apply the fact that at Brigham and Women's, we do it this way. And this is where our social services are. And this is the protocol by which you have to get a patient assigned to an inpatient bed before they do something else. And this is where our research projects are right now. And these are the available care plans. So you want to be able to have your data applied. You want to be able to have that available easily for retrieval augmented generation of whatever it is you're doing. You want to have agentic support. So as some of you and soon all of you will know, the world is now moving from AI that's responsive to your request and your chat to AI that's watching things by itself, that's looking at whole tasks, that's assigning subtasks and the rest. So you're talking about a foundation, a utility that can provide a family of orchestrating elements and a family of tools and skills. We sometimes postulate that there's maybe about 50 to 60 skills that can run a whole hospital if you design them right. So how do I make a model that can support those properly? It's something that we work on all the time. Model flexibility is important because the models change every 10 and a half days. There were 2 more in the last 4 days, not to mention a whole family of GPT, new ones. So, you want to be able to have the model that you're using work, and then you want to be able to adopt a new model where it's possible, and then go back and test that and make sure that you haven't lost anything in the transition. So being able to have a system that you can drop models into and out of and replace and measure the new things as they go on, all of these things are important. And that leads to the final element, which is you need to be able to measure, audit, trace, look for problems, see how people are using it, be able to extract data without holding on to personalized data. You really want to be able to measure how these are going, particularly in the still relatively unstable state of AI as we see it now. And all of that has to happen under that big blue circle in the middle. It has to be a secure system, scalable, performance system and so on. So we want this to be fast, we want it to be secure, we want it to be strong across all of the use cases that you're talking about. So, everything we've said today is really a general concept that applies to any system you have. Just to close, we'll spend a minute or two on how a large supplier like InterSystems works to bring all this together, since we think that this is a vitally important thing, and we are applying this to our systems in dozens of countries and hundreds of sites. So, InterSystems really starts with these large attributes. We've always been on the lower right there, an expert in healthcare interoperability. We supply 13 or 14 of the state HIEs. We supply the interoperability layer of the VA. We supply the foundation for all things Epic, support several small countries, and so on. So being able to support interoperability, we've learned a lot about what the nuances are, and make sure that we can do that properly. Along with that, we've been managing clinical data, well over 1 billion records, for a couple of decades. I think we're 45 years old and counting now. So being able to have that, and really the third thing now is over the past 10 years, really, we've really started to move rapidly and deeply in building up the kind of AI infrastructure that we showed on the previous slide. So all these things together, we think, is the foundation that we can build on, and we have several hundred people constantly building upon to be able to say, okay, this is now a much more capable data utility. So the data utility is the database, it is the governance of the database, it is the functionality that makes the data usable, and it's the ability to prove it, measure it, and learn from it across a pretty broad cross-section of customers, across health systems and health plans, technology partners and governments who really rely on this foundation every day. So I'll just say at the end that interoperability got the data moving, but the utility is what gets the data functional. And when it comes to AI, the functionality rules are similar, but they're different. The bar is raised. The uncertainties are certainly raised. So I think that you will see that it's really, really important to build on this concept of not just a database, but a data utility, a functional utility that can do this for you. So that's what we think the world is taking us to as far as data utilities go. That's where we think that InterSystems is going. And we'd be happy to talk about the few questions that are in the chat, and happy to have you visit the website or visit us. Thank you very much.
Thanks, Jonathan. And I'm unable to see the chat, but if you want to read those out, we're certainly happy to entertain them.
Yeah, there are 3 questions that came in. One says, this might be for some of the things you mentioned, what is a trusted research organization in all capitals, and how does that relate to the concept of the data utility?
What is a trusted research organization? It might be helpful to have a little bit more context there. So feel free to put more in there. So there's a couple things that stand out in terms of work that we've been involved in related to sort of validating and trusting that the data you're using is fit for purpose, as well as the AI you're using is fit for purpose. There's sort of 2 at least paths. One is that idea of entirely exposed closed loop communication in terms of when we think about building out AI solutions, whether they be chat-based or agentic, that idea that you can have end-to-end traceability to say, I can loop back and see exactly where that data came from, whether that's from an unstructured document like a progress note or something like that, or from a structured piece of like a CCDA that is incoming. I can see what's actually been done to it to clean it up, to aggregate it, to normalize it, right, to map it to all of the other equivalents. If you think about sort of all the different ways, for example, a hemoglobin might be coded depending on if it was ordered as a panel or as a one-off, those kind of things. I can see how that was done, and then I can actually see what the AI did with it to interpret it for some reason, right? Oh, this patient's anemic. And so when you have that, there's definitely what we see is this pathway of trust that's built with clinicians. What we also see is that from a vendor perspective, that it is absolutely imperative that we are able to articulate the processes we internally follow to validate the tools that we're building. In fact, what we've observed over the last, I would say, 18 months is the vendor-customer relationship has really continued to morph to a stronger partnership because it requires a level of trust and exposure to say these are the steps we follow to automate, to validate, to correct the tools that we're building to ensure that we deliver the right answers that are needed. And Jonathan, in fact, has been a part of some of these initiatives to ensure that we are actually actively validating and not doing that, given the rapidity, the frequency in which new models are released, how we do that model by model in a way that we can show that consistency and demonstrate it and expose it. So I think that there's multiple pieces there. Within healthcare organizations, we certainly have been involved in many of the sort of trust framework partnerships that are underway to say this is what we believe good governance looks like. This is a good pathway in order to facilitate all of the various steps that are needed.
Yeah, and I'll just add a couple of things. I'm not. I will say that I don't have the TRO as a all capitals thing. So maybe that's just my naivete. But as Julie says, we support, as do other people, we support a lot of organizations that are doing research in different foundations. So in a lot of the states, people are using our utility to provide the foundation for a different kind of research things. We have, and there's a number of different things that are involved in the research utility. One, of course, is protection and identifiability. You want to make sure that the right people are using the data that's theirs. If I have one utility that has a lot of data, there's going to be stuff that is needed for this project, but not for that, and vice versa. So you want to be able to have the ability to sequester and segment those things. So we provide data marts and the ability to configure those data marts. De-identification, obviously, is something that we do a great deal of, both the standard leave out the 18 factors, but also a lot more sophisticated things that make data non-identifiable, but also self-consistent, so that at least things are in the right date sequence and the rest of that. So that's another one. The third is just really the ability to always have provenance of the data, being able to see where these things came from, to look for any transformation that is made. I'd say there's probably about 5-10 points that are like that, which we do kind of implicitly, mainly, especially for some of the state data utilities, some of the international and national data utilities, that allow them to link that. So I think that's some of the ways we do it. Next question. There's more questions piling up now, which is okay. Someone asked, "What's the list of the 50 to 60 skills?" Oh, if you find out, tell me. I'm still working on them. But fundamentally, and I'll say some of this is in my head, but some of this is where we go. From 30 or 40 years of informatics work, you get a chance to say there are certain kinds of reusable functions, reusable data frameworks, and so on. And think about the functionalities from being able to view data, from doing orders, from care plans and protocols, from scheduling, functions like ADT and bed management, billing, and then in the research idea, being able to initiate research, being able to recruit for research, being able to run and execute research. So there's a number of those. I have in my own life on a couple of occasions written what I call the big functional outline, which is my caffeine-fueled document on everything that runs in the hospital. I sort 50 to 60 is a postulate, but I think that in terms of the number of, there's probably about 10 major divisions and probably about 50 major functions, and the rest you'll find will be parameters and sub-functions under those. So right now I'm doing that for Love and Company, so some of that's proprietary, but if people know me, they know that it won't be too long before I'm probably giving it in an AMIA talk somewhere. Someone wrote, "How is the data utility happening?" I have it's a little bit broad question to ask if you want to sort of make that more specific.
Well, I might weigh in there, Jonathan, just
Okay.
as a point, right? I think it's dependent on the technology. It's some of what the research has shown, and we've worked in conjunction with HIMSS, Chimes, all the sort of the AMIA, all of the big organizations to say how is this being done today, and what is it you want it to do, and where are the biggest gaps? And what we find across the board is that particularly in this new era where there are all the QHINs, the national networks, all of the different sort of HIEs and opportunities to share data, we very quickly, learn, if you haven't already, that you just end up with piles and piles of documents unless you actually enable the data utility features and functions. In other words, you actually have tools that can do some of that cleaning, that you're no longer relying on manual scripts or processes to cross-reference the data and align it to actually aggregate it, right? When we look at some complex patients within the systems, then we know that if you have a patient in a critical care unit for a month, just the sheer notes on that patient are never going to be read by a human. And so, but are there places you can say, well, this is where the meds changed, this is where the vitals trended, this is where the lab shifted in a way that actually can pull it all together meaningfully? Well, that gets back to the what does it need to do to get there? And I think there are those mapping questions, those standards questions, terminology questions, aggregation questions, to make sure then that it's actually pulled together meaningfully. And the good systems can do that with the technology and with the ability for a human to actually see what's happening in a way that actually engenders that trust. And we see a wide variation in the market of how many of those features and tools are available. But it's something that I think, to Jonathan's point, because we've been doing this so long, we really have the advantage of having built a lot of that in over the last many decades to really ensure that data utility is possible.
Yeah, and I'll couple that with the question, and I'll skip one, and I'll come back to it. But a question later on says, how does a data utility relate to domain-oriented data products and data mesh?
Mm-hmm.
I understand the concept of a data utility, but how does it get defined? Does it get defined as a cohesive data utility in some way, like all the analytic support for a particular decision pathway? And I'll just say, and then it says all the data resources. So it's kind of what you're talking about, Julie, which is that it's hard to if you try build these things one by each for each individual problem for a given support thing, it's not going to work. It's when we talk about utility in our context, we're always talking about let's give you the general framework, and we believe we have constructed the framework with we can convert our data to FHIR. We can convert our data to OMOP. We can convert our data to SQL. There's sort of automatic core tools for that. We can do data extraction in certain ways. We have an automated data mart facility. So we don't necessarily build for individual projects, but we build the framework and the configurability that people can use to support those projects. But you're right. It includes a lot of things. It does include support for analytics. It does include support for communication and exchange. If you happen to be a healthcare payer, it supports the ability to do things like transfer a patient's data when they decide to change payers, as the government requires, and so on. So a lot of this is, utility with a capital U. In other words, way down at the bottom in such a way that it can be kind of a stem cell utility and can be repurposed in a lot of different ways. Mayank, you clarified your question, talked about, yes, the British trusted research environments, which I have heard of, not in depth, but we do get involved with them. We have a whole ton of stuff. We support a lot of the firms and data centers in UK. And yes, as I understand the trusted research environments, they are particular qualities of computing environments so that they have certain thresholds of security and access and sort of efficiency and performance. So I can get you, if you want, more information on the details of how we're doing that. But that is a sense, and we see that elsewhere. We see the same thing in the Middle East. We see the same thing in Thailand and other Southeast Asian countries. that they're all looking for the same general thing. And like I say, we try and provide this on a general nature. We can get you more specifics if you wanted to know about the UK specifically. Couple more. Can you explain data cleanup and normalization? Do you mean that an InterSystems AI would do that, or another tool, or something an organization should do prior to using that data in AI? I'll start, and Julie, you can grab on. So data cleanup and normalization is something we've been doing about 40 years before the current thoughts about AI have come around. Frankly, a lot of the data cleanup and normalization techniques we've had have been, started with brute force, and they really are based on, having a family of transformation tools. We look at a customer when we go to a new customer. We'll say, let's look at all your data, and we look at that and we say, oh my God, yeah, it's one of those. And we find that that the admissions are in 15 places, and the patient identifiers are in 12 more places, and some of that is semi-automated ability to go through that data and be able to say, okay, these things belong to these things, and a lot of it is kind of hard work to map these things into the core reusable data structure that we can use. Now, AI will make that happen, make that better, and we are using AI now to be able to speed up that process of being able to break down and understand the data framework of new customers or customers that have new data models. So AI is helpful, but it's something that an organization should do early on. But very often what happens is that we see the organizations don't really have the stomach for that, and it winds up being something that's an InterSystems function. Julie, any further on that?
Yeah, and I might even add on to that a little bit. I think that's part of where we see that it's gone a little bit downstream in terms of the awareness of it. So, to Jonathan's point, we've been doing this a long time, which is all sort of technology-based, coded solutions of how do you clean something up? What is the right way to map it? How do you ensure that whether something comes in as an RX norm code, or as a SNOMED code, or as an ICD-10, or maybe it doesn't even have a code, how then we actually marry those together. And, if you think about some of the hierarchies in terminology specifically, then you might realize, you have diabetes, then you have, all of the flavors and variations therein. And when do we consider them the same versus different? And how do we reconcile that? So we have been doing that for much longer than people have been using Gen AI. Can Gen AI accelerate that? Yes. As long as we still follow the same principles of saying, but do we understand what happens? Can we actually see what was left behind if it really means the same thing? And then, of course, AI can actually answer some questions in a more rapid fashion of just racing through that data to say, does this patient have diabetes? Now it can cross-check to say whether it's in a codified version versus an unstructured text version versus some other reference that implies that they have diabetes because if they have an A1C reading, for example, then AI can solve for that too. But what we're finding across the board, across all of our customer base, whether that be, to Jonathan's point, health plans or IDNs or smaller community places or HIEs, is that it all goes back to what is that giant bucket of data that we're starting with, and have we made it into meaningful packages that AI can consume, absorb, and then interpret. And if we don't clean it up enough before it gets there, it's a garbage in, garbage out scenario. And so it really requires those skills of harmonizing it and mapping it and transforming it, where it doesn't matter if it came in through a FHIR API or through a CCDA, or maybe even as a flat file or X12 or any of those other formats that are out there. We can then say, yes, but these are truly the same thing, or no, they are not. Right, as an end user clinician, I don't want to see the penicillin allergy 55 times because I have 55 records. I want to see it once. And so how do I know that versus where if I have a medication dosage change, I want to actually see all of those dosage changes. And so we've built out that logic in a way to do so. And I think AI certainly offers opportunity to accelerate that. But it's relying on those foundational skills that are necessary to actually make the right decisions up front for then to give that guidance to AI to do.
Great. There's one more question at least. And Mayank, I see your additional information. Yes, you can write me also, Jonathan.Teich, Teich at intersystems.com, and send me that same information because I'm not sure how long this chat will survive, and we'll try and put some certain things together. Gusa Nakatani, as a health informatics background person, what is my role in data utility and governance? Well, you're talking to two people who have health informatics backgrounds. It's funny. I've been chairing an ACME group on sort of how career paths can move towards this kind of thing, and particularly into things beyond just academics. Your role is that you know two things. People in informatics know what computers can do, and people in informatics know what healthcare needs. And even in today's day and age, not that many people know both of those things. So when you think about data utility, you know what are the efficient strategies for storing data, but you also know that not every piece of data is going to be something that you need for every purpose. You're going to know that certain ways of organizing data are going to be much more useful. You're going to know that red cell distribution weight is not necessarily a very important test to have a lot of the time. So maybe that's not the most efficient part. And that's only a trivial example, obviously, but it's one I'd like to make fun of. I think that the answer is as much as you're willing to kind of get out there and do. In most systems, people are hungry for knowledge to appear as to how to organize this. And I think that one thing that's important is to think about it from the perspective of what you're trying to solve, because your CIO and their staff are thinking about it from what's the best way to store data and the least expensive, and the rest also important. But you can come at it from the standpoint of, if I'm running a research enterprise, if I'm running an ICU, if I'm running an emergency department, how do I need to have data together? If I'm trying to get information that patients can use, what do I do? So think about things from how things should be organized. And I think that's a starting point. And you're also welcome to write to me. I'm happy to talk to you about sort of personal training issues. And Mayank, I see you've read Jesse Tenenbaum's book, which is a very good choice. I think Jesse might be on this call. And certainly one of my best friends and most respected people in the whole field. So I think that's a good choice. Asif Syed, who always asks good questions. What role do you see for ontologies within a large academic system AI deployment? You want to start, Julie? No.
What a question.
Okay.
Well, I mean, I think there's always a place, right? Because ontologies are one of the mechanisms in which we use to map and normalize data in a way that makes it useful. And so I think it's essential that we can do that and leverage it. And so those are constantly being developed. We are very much sort of engaged with many of the standards bodies and in order to make sure that the decisions made, I think back to the health informatics question of to be the translators of what is needed for the use cases, what is needed in clinical practice, what is needed in healthcare leadership, organizational, operational functions, and how does technology work, and how do we actually pull those together to be something meaningful? And I think ontologies are a big part of that.
Yeah, and I think I mentioned briefly that we support, we've got a whole dedicated channel for moving things to FHIR. We've got a dedicated channel for moving things to OMOP. We've certainly worked with all of the IMOs and the health language and the clinical architectures of the world, and many others who are overseas that you may not have heard of. I think they're important. I think they're important to the extent that they can organize information. I think they're important to the extent that, I can find a grouping which kind of looks like the way I want to organize medications. I can remember long ago when I was building order entry systems that I picked on a particular level of what's now RX norm which happen to be the right one to group medications at a prescribing level. And we use that, something similar to that, in InterSystems because we have this will be pertinent to the next question also, but we have a medication that the same medication coming in from 6 different sources in slightly different forms. 2 generics, and one has the dose and one has the route. So I think that being able to group them, being able to understand the right granularity for any given problem, makes it worthwhile for a data utility to understand either all of those levels or to at least have an index to get to all those levels. And I think the last
All
question.
right, Jonathan, we got time for one more. That's it.
Yeah, we got one left, and that's we're going to close after that, and this will be a fun one. I think I'll stick you with this, Julie. How do you address lab data interoperability, considering that lab reference values are different from one lab to another?
That's right. Well, I mean, one of the great things is that our development platform is actually used by some of the largest lab vendors in the country, and so we have a lot of exposure here. But the reality is that you have to think about clinical safety in all things that have clinical data. And so that means that if there's a different reference range, then you need to expose that. That doesn't mean you can't aggregate at all, but you have to surface what is meaningful for the use case that's being tracked. So at a population level, we certainly see this with population health analytics. We certainly saw this in the pandemic, where we were tracking vast amounts of data related to vaccination rates and infection rates and all of those things. That you have to ask the question: does it matter for the question I'm answering? And if it matters for the question you're answering, then it needs to be exposed. And labs are notorious for being incredibly complex in the sense of different reference ranges that are needed, or even over time, right? Not just from different institutions, but you see the sort of the within normal limits shifting. There's been a lot of those in recent months that have shifted, and so being able to expose what we received, what the context of it was for that moment in time from that entity, and then cross-referencing it with the others in a way that then the person seeing that data can use it meaningfully.
Yeah, I mean, I've always thought that the normal value for every single lab should be 1. And the people that invented INRs did this beautiful thing. And it's been surviving for, I don't know, 30, 40, 50 years. I'm not sure how long INR's been around. But everybody else is changing this and changing that. And like Julie says, we store all the lab values with the lab reference values. And sometimes you just want to know the trend of the labs themselves, and sometimes you want to know whether they're abnormal or normal. And sometimes we have these graphs where not only is the dot moving along the graph, but the green shaded normal area is moving along the graph. And I think that for some of these, it's a difference that's probably more granular than you need for most things. All right. Well, that's about it. It's been a blast, and it's a fascinating area. Just how much AI and data and all this go together, and we're really changing medicine before our eyes here.
Well, thank you, Julie and Jonathan, for presenting today. Thank you to InterSystems for sponsoring the webinar, and thank you to everyone who attended. Have a great day.
Thanks, everyone.
Thanks, folks.